Hello everyone. So today we will explain to you about our IIEC project, which is Light Microscope for Kids, the creation of new learning techniques of microscopes for kids. This is our teammates that makes everything become possible. Dina Iza binti Abdul Ghani, Nur Najiha binti Rizal, Siti Nur Aisyah binti Muhammad Azmi, and lastly, Imanakia binti Ahmad Haris. The field of study for our IIEC project is using biotechnology.
Does microscope for kids help in their studies in the 21st century learning? The hypothesis is the mini light microscope are effective for kids to learn and explore science with real things and make them love science.
The objective is to give early education to the kids about the introduction of microbiology and produce more professional scientists in the future by creating a mini microscope to the kids. The process is, first of all, we prepare the hardware component and the optical glass. Next, we making the lenses and the mirror. Then, we assembling the microscope, and finally, we working principle of the microscope.
The literature review about microscope is that microscopes are specialized optical instruments designed to produce magnified visual or photography, including digital image of objects or specimens that are too small to be seen with the naked eye. Collectively, these varied groups of tools includes not only multiple E-lens compound microscope design featuring objective and condenser, but also consists of very simple single-lens instruments that are often handheld, such as a photography loupe or common magnifying glass. Utilizing a microscope is a proficiency that can be readily learned by almost everyone. Even though at first the complex array of switches, filters, knobs, sliders, eyepiece inscription, and colorings on the objective may be confusing, they are really deciphered in a short period of time. The methods of operation are based on convention that seldom change, so once a novice has begun to understand and apply the basic principle of the technique, success is almost certainly within reach. Many years of practice, improvement, and asserting individual creative changes to the standard methodology can ultimately transform to the beginner into a master microscopist. Due to the fact that a large number of microscope users rely upon direct observation of the specimen, it is critically important to understand the relationship between the microscope and the human eye. Regardless of technical advancement, the human eye as a visual detector in combination with the brain is the most efficient image processing system that has been encountered. There are no man-made devices that can match the abilities of the human eye in regards of imaging speed and resolution. The principle of operation underlying modern cameras, however, are strongly related to the structure and operation of the eye. As you can see, this is the anatomy of the human eye. Together with the muscle-adjusted lens, the curved surface of the cornea projects an optical image onto the retina, the detector. The level of incident brightness is controlled via the variable diameter of an iris, much like an optical diaphragm under the control of specific muscles. A sharp image is produced by the flexible lens, the focal length of which is changed by another set of muscles, so that focusing is possible on any object at a distance between approximately 2 centimeters and infinity. The image itself is detected on the retina by approximately 130 million photoreceptor rod cells responsible for recognition of gray levels and 7 million photoreceptor cone cells for color recognition, and is then transferred to the brain along the shortest possible path through the optic nerve. The concept of magnification is that over 500 years ago, simple glass magnifiers were developed to assist with viewing very small objects. Such instruments consisted of one or more convex lenses, thicker in the center than the periphery, that allow a specimen or object to be focused by the magnifier position between the object and the eye. Sometimes referred to as simple microscope, They display the image on the retina by magnification through a process that increases the visual angle on the retina. The image is perceived by the eye as if it were at a distance of 10 inches or 25 centimeters. Although the image of the specimen appears to be on the same side of the lens as the specimen itself, it cannot be projected onto a screen. Such images are termed visual image, and they appear upright, not inverted. In a compound microscope, the image appears to be floating in space just below the top of the observation tube, where the eyepiece is inserted. What you are observing is not tangible. It cannot be grasped. Rather, it is a map or representation of the specimen in various colors and/or shades of gray from black to white. More than an 8-fold or 10-fold magnification is not very useful with a simple biconvex lens because of the resulting small field of view and the fact that the lens must be brought into a very close proximity to the eye. In order to achieve higher magnification, we must use the compound microscope, which has originally developed by the Janssen brothers in the Netherlands and Galileo in Italy around the beginning of the 60s. In its simplest form, the instrument is composed of two convex lenses aligned in series. An object glass, more commonly referred to as an objective, closer to the object or specimen, and an eyepiece ocular lens closer to the observer's eyes, with means of adjusting the point of the specimen and the microscope lenses. The compound microscope achieves a two-stage magnification where the objective projects a magnifying image into the body tube of the microscope and the eyepiece further magnifies the image projected. The total magnification equals the magnification of the objective multiplied by the magnification of the eyepiece.
The problems that we need to face are: first, what kind of material we should insert to make our mini light microscope easier for kids to bring and use. Second, how far our mini light microscope get the attraction by consumers, parents or public people. Third, children nowadays are not aware about things around them, especially environment. They don't believe that bacteria and viruses are all around us, which are very harmful to us. There are 6 limitations about our products. These are sample size, financial process, time, method, sample profile, and fluency in language. The conclusion that we can conclude about our product is the light microscope is a very powerful tool for understanding the structures and function of tissues, and it is widely used in biomedical science course as well as in research and diagnostic laboratory. Next, understanding the capabilities and limitations of the light microscope is important if one is to get the best result of microscope. The ability to identify structures and specific cell types has been greatly aided by different staining techniques and more recently by immunohistochemistry. Lastly, the investigation of cell structure has been considerably extended by the developments in electron microscopy and fluorescence microscopy.
This is our bibliography, and this is the end of the video. Thank you for watching.